Hello learners, I am Karesh Fondekar, Assistant Professor in Physics at Ganpat Parsikar College of Education. In the today's physics course entitled Everyday Physics with Demonstration, we are going to learn a new topic, that is the magic of light. So let us start with the topic, the magic of light. So what is light? We have many definitions for light. So let us understand what is light. Light is a form of energy. Light is made up of photons, which is a packet of energy. Light is an electromagnetic radiation. So what is electromagnetic radiation? You can see on the screen, there is electric field and magnetic field oscillating. So there is a wide spectrum of electromagnetic spectrum. So here you can see it goes from gamma ray to the radio waves. Here there is a small region which is visible, which we can see. That region we can see. Other regions like gamma rays, extra, ultraviolet, we cannot see directly, but we have many instruments. We use it for many purposes. So we cannot consider a light which the spectrum which only we can see. So it is the combination of complete spectrum. So effects about light. Light does not require a medium to travel, like sound. Sound requires a medium to travel, but the same is not in the case of light. Light does not require a medium. The speed of light is 3 into 10 raised to 8 meter per second square. Light wave is a transverse wave. Light always travels in a straight line. That's a Fermat's principle. Now we will see some properties of light. First, reflection. The reflection of light occurs when light is bounced back from the surface. Then we have refraction. Refraction is nothing but bending of light as they pass from one medium to another. Then dispersion. The process of splitting of white light into spectrum of its color. So if you must have seen the rainbow. Rainbow is the best example of dispersion. Then TIR, that is total internal reflection. It is a physical phenomena that occurs when the light ray is completely reflected back into the medium it originated from. You must have seen in daily life, in summer, the road seems to be wet, or there is you feel like there is a water on the road. But if you go there is nothing like that. It is because of the total internal reflection. Then we have scattering. Scattering is a phenomenon that occurs when light passes through a medium and interacts with its particle. We will see the simulation of all this using a simulator. We have here a simulator. Okay, just now we have seen the simulations of the properties of light, like reflection, diffraction and so on. Now, we have one question, that is, why sky is blue and sunsets are red? If you see sky, it looks blue, but in the evening or the morning it looks red. What must be the reason? We know that sunlight is a combination of all colors in the spectrum. When sunlight strikes with particles of size much less than the wavelength of all colors, the light gets scattered. Blue light has the smallest wavelength. Thus, it gets scattered the most and the sky appears blue during the day. If you look here, in the morning, the sunlight has to pass from the atmosphere. It is a thick region above the Earth's surface. When in the afternoon or in the non-evening or non-morning time, the light has to travel a smaller distance. So, since the wavelength of blue is less compared to the red, it scatters most, and that's why you can see the sky blue. Whereas at the time of sunset, the sky appears reddish. So during sunrise or sunset, sunlight travels a longer distance through the atmosphere. Thus, all the components of the light get scattered. and what remains is the red component. That's why the sky appears reddish. So that is the result. We will see this with a demonstration. Now let us understand the phenomena of scattering and let us understand why sky looks blue in the day and sunsets are red. So let us understand with the help of an example. I have taken a bottle of water and I filled this bottle and I have added some bleaching solution. So it's make a colloidal solution and I have a white light. Let us understand the phenomena of scattering. So when I pass this light, white light, through this solution, you can see the phenomena of scattering. That is, light is interacting with the medium. Here it is a solution of a bleaching powder. Now, let us understand why sky looks blue in the day and sunset and sunrise looks red. Here, if I consider this as a Earth's atmosphere. In Earth atmosphere, we have different gases. Here it can be you can consider it as a solution, that is a colloidal solution of bleaching powder or bleaching solution. If I pass a white light, you can see a bluish color. You can see a bluish color because of a white light because of the scattering. Now this can be the case of as in the case of morning time. Now what would happen at the time of sunrise and sunset? The light has to travel a greater distance. So I'll take this bottle, I'll hold this bottle vertically and I'll pass a light. Here you can see a bluish color. As you go on top, you can see some yellowish or reddish there. That is because the blue light is completely scattered and what remaining goes further. So you can see it is not exactly red, but you can just take this example for in case of demonstration. So you can see a reddish color on top. So this thing happens at the time of sunset or sunrise. Thank you. That is reflection and refraction. So reflection occurs when light is bounced back from the surface. Here you can see the light has already bounced back from the surface. Here you also can see refraction phenomena, that is bending of light as they pass from one medium to another. Here you can see there are two mediums. On the top it is material air, or you can say medium is air, and second is water. Here you can see the light has gone through reflection and refraction. Now let us understand another phenomenon, that is TIR. What is TIR? That is total internal reflection. That is a physical phenomenon that occurs when a light ray is completely reflected back into the medium it originated from. So let me change the medium here. Let me make this medium as glass. Let me change this to air. Here you can see when the source of light emits light, that light undergoes reflection and refraction. When I change the angle of incidence, you can see the reflected ray and refracted ray changes its position. At the point, the refracted ray will coincide with the material. Then after that, it bounces back to the same surface. This phenomena is nothing but total internal reflection. Now let us understand the phenomenon dispersion. So here I am taking a source of light. Let me select a white light, that is a source of light, as a source of light. Now I will take a prism. So what should happen in dispersion? What is dispersion? The dispersion is the process of splitting of white light into its spectrum of colors. When the source of light will emit a white light and it will go through a prism, it should show me a spectrum. So let us see. Here you can see when white light passes through a prism, you get a spectrum of light. This phenomenon is nothing but dispersion. So these are the reference books you can refer, and thank you so much for your attention.